Okay, so welcome to this. This is the Further Math Support Programme online revision session for OCR Statistics 1. And in this session, we're going to be looking at correlation and regression together as one topic. There's a lot of similarity between these. So you need to be able to calculate the product moment correlation coefficient, which we call PMCC, and its symbol is R. And we also need to be able to calculate this thing called Spearman's coefficient of rank correlation. In some books, you see this referred to as Spearman's rank correlation coefficient. And its symbol is R with a subscript S. PMCC demonstrates linear correlation. Spearman's rank generally just deals with a correlation. We need to be able to interpret these correlation coefficients. So if it's got a value of 0.3, what does that actually mean, for instance? We also need to understand how coding is affecting these coefficients. In terms of regression, we need to be able to calculate this thing called a least squares line of regression, and also look at how coding affects it, and also about how we use the model. So the formula sheet is quite cumbersome, with quite a lot of information, and generally you're given summative statistics to start off with. So usually this end of the formulae for SXX, SYY, and the like are the most used ones. They may give you a question where they're actually giving you these values, but generally the ones I've boxed are the most useful. Also, that is really all you need to take from the PMCC. That's the formula, that's the calculation, and then you just use the values that you've previously calculated to work this through. So there's no real need to use this pretty horrific looking thing at the end. You're also given Spearman's rank, and we'll go through this a bit later on anyway. The regression coefficient of y on x is also given to you. So again, this thing is the gradient of your regression line. And also we're told how we find the y-intercept in context as well. So again, we rarely need to use that aspect of it. The important thing with the regression is it tells you which is your dependent variable. So if it says regression line of y on x, y goes on your y-axis, x doesn't. So if they tell you find the regression line of m on h or something like that, then m is your dependent variable and must go on the y-axis. So a lot of students struggle about what goes on which axis, and that's a real sort of good rule of thumb to help you with that. So straight into a question. We've got the heights h and weights m of 5 men, and they were measured and they were plotted on this diagram. Okay, sometimes you're asked to create a scattergram from scratch, but generally they are given if required. And we are asked to use the summative data, which is this data down here, to calculate the value of the PMCC. Okay, so the first thing you need to bear in mind is you've got different variables. So it's a really good idea to make sure that we are using the correct letters. Okay, so I'm only going to work out one of these. The other two pretty much follow the same pattern. But SMM is going to be the sum of m squared minus the sum of m all squared over n. Okay, now you get one method mark for getting one of these correct. Okay, so you get your first mark in this question by ensuring that one of these is correct. The other two you get no marks for, but obviously you need them. So, they don't give you lots of marks for these. So let's look at SMM, make sure we're happy with that. So that's going to be the sum of m squared, so 28558.67, minus the sum of m all squared, so minus 377.7 all squared over n. Okay, so in that particular context, SMM is going to turn out to be 27.212. Okay, so just to give you the other ones as well, you would need to work these out, obviously. We're going to get 0.2412, follows exactly the same pattern. SHH will give me 0.10992. So now we're in a position where we can calculate R. Okay, so the formula is R is equal to, now applying it, we get SMH divided by the square root of SMM SHH. So your next mark, your method mark, is then for substituting. Now notice SHM and SMH are identical. Okay, it's a symmetric little formula. It's really quite nice. So just be aware of that because sometimes it's necessary. So we're going to get 0.2412 divided by the square root of 0.10992 multiplied by 27.212. Okay, so that's where your method mark comes from. So you get a B mark for that. And then of course your accuracy mark is for getting the correct answer to the appropriate degree of accuracy. So these are quite nice. You just need to know how to apply your formulae in these contexts. So we're then asked to comment on the value of R in relation to the diagram. So let me just remind you, R was 0.139. Okay, now R is a measure of correlation. 1 means it's a perfect positive correlation, -1 means it's a perfect negative, 0 means that there is no correlation at all. So here, first of all, we need to comment on that. So here, R is close to 0. Okay, so this implies, if you wish, just as comment, but it implies that there is no correlation. So that's 1 mark. Okay, we're asked to see how it relates to the diagram. So your second mark is to say that the points, okay, don't seem close to a line. It doesn't make sense in my view. If you look at this, it doesn't really make sense to draw a line of best fit. Okay, so the points don't seem to be close to a line. Therefore, you would expect a low correlation coefficient. Okay, so that's quite a nice question. So you get 1 mark for each of those describing aspects. It was then decided to recalculate the value of R after converting the heights to feet and the masses to pounds. So this, at the minute, the height is in meters, and here the mass will be in pounds. So effectively, we're going to code, and the axis will change. So roughly speaking, this will be about 4.5, this will be about 4.8, etc. And these will be about 100 and... I'm only estimating because I'm going to tell you something interesting. So if I do it in pounds, this is going to be about 154. This one's going to be about 168, and so on. Now the important thing to realise is, all I've done here, this is coding, all I've done is change the axes. The points themselves haven't moved. So as a consequence, when we apply coding, coding does not affect the relationship between the points. So it does not affect PMCC. So R is still 0.139. Even though I changed the variables, it doesn't affect the coding. So that's quite a standard question. It does affect each of your SHMs, SMM and SHH, and I advise that you make sure that you are aware of how they change. They are variances, so coding will affect them, but PMCC is unaffected, which is quite nice. So you get 1 mark for basically stating that fact. It then says one of the men had a height of 1.63 meters and a mass of 78.4. So it's a good idea to think about where it goes. It's this person here. Okay, the data for this man was removed, and the value of R recalculated using the original data for the remaining 4 men. State what we think is going to happen. Well, this point really, if you look at it, was an outlier. By removing it, you can sort of see that it now makes sense to have some form of a line of best fit. So because it now looks as if there should be a line of best fit, we can state that R is likely to increase because it's more clear. Okay, now it's not asking for reasons, it's just asking for you to state why you think. If you want to state reasons, you can then say because it looks as if the data is more on a straight line. So that's quite a nice question in total. Okay, so this question we're now talking about skaters. 3 skaters A, B and C are placed in rank order. That's a key word there for you to understand that we're going to do Spearman's rank. So they're placed in rank order by 4 judges. Judge P ranks skater A in first, B in second and C in third. And what we've got to do, this is interesting, without carrying out any calculation, state the Spearman's rank correlation coefficient. Now, what you can see here in this question is they are in complete disagreement with each other. Okay, they've ranked perfectly oppositely. So what that means is they're in perfect negative correlation. Okay, so we're going to work some things out with this in a minute, but because they're in exact opposites to each other, you're going to have a negative correlation. Okay, so the reason for your answer is because it's reverse ranking. If it was in agreement, perfect agreement, then RS would equal 1. It's only when they differ from that that your Spearman's rank coefficient will drop. Okay, so we're now asked to calculate Spearman's rank. Okay, so to do this, I'm just going to give some advice as well. What we do is, the formula is RS is equal to 1 minus 6 lots of the sum of d squared over n squared minus 1, where n is the number of people, okay, and d is the difference between rankings. So here I've got minus 2, here I've got 1, here I've got 1. Now difference, I know that difference is technically always positive, but there's a little useful check here. If you don't do that, your differences must add up to 0, so it just allows you a quick check. Doesn't really matter because actually it's d squared that I'm interested in. So in this particular case, I'm looking now that the sum of d squared is equal to 6. So we now apply the formula, so RS is equal to 1 minus 6 lots of 6 over, now n is 3 in this case, okay, so that's going to give me 3 squared minus 1. And if we calculate all of that, that's going to give me a value of minus 1/2 if you work that all through. Okay, so be useful to know where your points are. You get 1 mark for trying to work out the sum of d squared. It doesn't matter if that's correct or not, but you get your method mark for that. You then get another method mark for applying the formula, and then you get your final accuracy mark for getting minus 1/2, or 0.5. Minus 0.5 would be equally fine. Okay, so that's quite a nice question, really. Okay, so now looking at January 2011 question 3. A firm wishes to assess whether there is a linear relationship between annual amount spent on advertising, X £1,000, units are very important here, and the annual profit Y in thousands of pounds. A summary of the figures for 12 years is as follows. So again, you can see that we're given all of our summary data. So we're asked again to work out PMCC. Okay, so we are looking at X and Y, so that's fine. So reminder, PMCC is SXY over the square root of SXX SYY. So we need to work each of those out. So SXY is equal to the sum of XY minus the sum of X, sum of Y, over N. So I'm picking a different one to calculate this time, so you can see, so 7351.12 minus the sum of X, which is 86.6, times by the sum of Y, which is 943.8, all divided by 12. You're going to calculate the others in exactly the same way as we've done before. Okay, so I'm only going to calculate this one, because again, I've shown you how to do SXX in a previous example. So it all follows the same sort of maths. So this is going to be 540.03. For reference, SXX and SYY will take the values of 33.80 and 9433. So now we can calculate R. Just change my ink color. So R is equal to 540.03 divided by the square root of these two multiplied together. So 33.80 times by 9433, which is going to give me a value of 0.956. Now again, 3 sig figs is the standard, so that's what we really should be using. So again, how are your marks allocated here? Well, you get 1 method mark. It's not a B mark this time, it's a method mark. You get 1 method mark for calculating one of these things. You then get 1 method mark for working out R, and then you get your accuracy mark when you get the correct answer. It then says in the second part of the question, comment briefly on the value in this context. This is the key thing, in this context. Okay, so if you just tell me this is a very strong positive correlation, you might not get the marks. Okay, we really need to make sure that we are applying, in my view. So we need to say that there is a strong positive correlation between the amount spent on advertising and the annual profit Y. Okay, the key words here are the fact that we want the word strong agreement or strong correlation, but we also need the words. Okay, and that will get you the method mark there. Each board is slightly different about what they're looking for in those types of questions. Okay, so now we're starting to analyze the situation in a bit more detail. So a manager claims that this result shows that spending more money on advertising in the future will result in greater profits. Okay, now we're asked to write two criticisms. Now what we are doing here is we are extrapolating. Okay, we are looking at what might happen in the future. You're not allowed to do this. Okay, your model is only valid for your data of your independent variable. Okay, so extrapolating is not possible. So that's one criticism. Okay, so that's all about the fact that your model is not valid in the future. The other one is this. Correlation, this is quite important, correlation does not imply causation. So just because you can show there's a correlation doesn't mean that there is a cause. In other words, that one thing has affected the other. So they're the two criticisms about this claim. You get 1 mark. These are B marks, so you get 1 mark for each. Okay, so we're then told what the model is. Now you have to work this out. So I am going to briefly show you, even though it's not part of the question, I'm going to show you how we work this out. Okay, so the model is y is equal to bx minus a. So we've got to work these things out. So we're told that b is equal to sxy on sxx. So we're finding the least squares line of best fit in this context. Okay, so sxy over sxx is what we're looking at. Now we've already worked these out. Okay, we worked out that sxx was equal to 33.80, and we'd worked out that sxy is equal to 540.03. Okay, so if you do that calculation, you'll see that you get 16.0, which is exactly what we had here. Okay, so that's great. We're then told that a is equal to y bar minus bx bar, and this is the equation that enables me to find a. It comes from substituting the point x bar y bar into the linear model because we know these points. So a is equal to, now y bar is going to be 943.8 divided by 12 because it's the mean of y, minus 16.0 times the mean of x, which is 86.6 divided by 12. So that enables me to calculate a, and again it turns out that a is quite nicely minus 36.7. So as a consequence, my model, y is equal to bx minus a, becomes y is equal to 16.0x minus 36.7. Okay, so in a question like this, it's usually worth about 3 marks. You get a mark for working out the b, you get another mark for working out the a, and then you get a final mark for getting y to be correct. So now we're asked to estimate, let me change the color again, we're asked to estimate in this question the annual profit when 7,400 was spent on advertising. Now this is where units become important. So this is an x value of 7.4, and that's really important. So y will equal 16.0 times by 7.4, and again it's 7.4 because we're talking already in terms of thousands, minus 36.7. You can't just put 7,400 and expect it to all work out nicely. So by calculating that, that's going to give me a value of somewhere between 81.4 and 81.75. Again, that's because of rounding. Okay, there's all sorts of rounding issues that you can create from this, and because I've rounded values here and here, so they are quite lenient about that. But then of course you need to put it back into context. So y really, or the cost, sorry, profit really is 1,000 times that, again because of the units. So your profit should be around about 81,400, and you get 2 marks for that. Okay, you get 1 mark for using the model, and you get another mark for using and finding the accuracy. Okay, so that's a whistle-stop tour of correlation and regression, and really the questions are quite similar to that. They don't really deviate much from this, but again, you've got to be really careful that with regression in particular, you're using the correct letters. So for instance, let me just use this as an example. If your units were m and h, and you decided to write an equation in terms of y and x here, you will lose marks because the model isn't correct. You must use the letters given. So I hope you found that useful. Please go through all exam questions on these and practice them. As I say, they don't really differ much from this, but you just need to practice.